Hello, everyone. My name is Mr. Ryan Kish. I am the teacher for Digital Electronics. Welcome to the open house video. Digital Electronics is one of our Project Lead the Way courses, part of our pre-engineering sequence. It is open to all students who have taken at least Introduction to Engineering and is a great complementary class to Computer Science Principles, where students learn the programming side. Digital Electronics is really more about the hardware side of computers and electronics. So what is digital electronics? My definition is it's the study of electronics and computer hardware and logic systems. Computer hardware, I have in quotes there. While most of us think about our personal computers as a computer, largely the types of computers that we are talking about in this class are kind of standalone computers, the kind of computers that you might find in your car, in an airplane, in some of the appliances around your house. They're computers that have one very specific job and they kind of live on the machine. And much of our learning is also the basis, though, of our personal computers that we mostly know. Obviously, these systems are much more complex, but really they are one and the same at the root. Just a quick rundown on the course outline and some of the topics that the students will be learning about. So we have Introduction to Electronics. Students learn the various components that are associated with electrical circuits and digital electrical circuits as well. So we've been covering how to read and identify the different parts and how to understand the values by looking at color codes or other codes that are printed on the items. Students will get to learn to use a digital multimeter, which is the picture in the lower center here. Mostly we're starting by reading resistance, voltage, and amperage in circuits, in basic circuits, to gain an understanding of how they work. We will do some soldering. Each student will get a few soldering projects that we'll do at the beginning. We will use some of the projects that the students build to serve as kind of a learning item for the rest of the class as well. And we will discover all of the various parts in the soldering project and how it actually works. And that is kind of by design in the class. Students will also learn to do some very basic breadboarding at the beginning here, basic wiring. We put some LEDs together with different resistors and those types of things. And we will continue to build upon that skill throughout class. In Unit 2, we begin to look at AOI circuits, which stands for AND or inverter. And these are the basic components of all logic and computer circuits. It's a bit of a history lesson, but they are universal in the sense that they're still really used today. There's many more of them and they're much more complex, but it is really the same basic control circuits that are used throughout all of our modern technology. So students will get to experience and understand how they work, designing them on the computer. They will also get a chance to breadboard and wire up circuits that actually use these types of gates. We'll learn how to wire integrated circuits, which are the little black chips down on the lower part of the screen, and understand how those function, and actually design and test circuits that are built with those. Students will also have some design projects. So once we learn some of the basics of how these circuits work, they'll be faced with a challenge in which they have to design a circuit that will meet the challenge. So they'll design on the computer, and then we will wire it up and physically get it to work on the breadboard as well. A little bit later in the unit, we introduce the concept of programmable logic devices, which is the lower left one here. And this is basically a reprogrammable chip that can be used to accomplish a similar thing that is happening on the right-hand side here with a lot less wiring. And there's a discussion amongst that of cost versus ease of use. And that's a real concern out in the design world and the engineering world surrounding these types of devices. Our third unit will deal mostly with counters. We look at asynchronous and synchronous. Counters basically allow us to create different types of timing and have circuits that run based on time, and also circuits that are kind of always looking for events to happen, also known as event detectors. These are the types of things certainly what you would find in your vehicle. So when your brake fluid is low or when a tire goes low, those types of sensors are going to sense and send out information to you that there's a problem, but the computer is always looking for those possible events to happen. So students will learn how to create timers, both again on the computer and on the breadboards. We also introduce the digital display here, a very basic one, but still used in some technologies today as well. All right, and finally here, just a look at the grading breakdown. So essentially, we have about 5% homework. There's not always a ton of homework. Generally, it is assigned when students don't complete the activities that are assigned in class. So, I try to be understanding of the pace of class, and we adjust when things are due accordingly. But if a student is behind, or maybe they just weren't optimizing their time in class, then some of those activities may become homework so that we can move on to the next lesson as a group. About 35% of the grade is the weekly learning activities. These include worksheets and labs, which are kind of combined together. So, as students are learning, we're also then, again, designing on the computer, testing on our knowledge, and then doing activities to kind of get the hands-on experience of that learning as well. About 40% of the grade consists of our major projects, tests, and quizzes. There is also a midterm and a final for the class, and those are each 10% of the final grade. The major projects, again, include big projects that students are doing at the end of each larger unit to kind of confirm all of their learning. These are usually design projects, so the answer is not really given, and sometimes there's multiple ways to solve the problem. There are major tests, and there are also quizzes throughout the class. I do have a late work policy. Students work is due on time. There is a penalty for late work, but it is still accepted and encouraged. I also encourage students to correct their work. So if there is an assignment that was given back and they did very poorly on it, maybe they got only 12 out of 20 points, I highly encourage them to come talk to me. Let's review what was wrong. I really value that they have a good understanding of the material before we move on. A lot of the information class does build on the previous learning, and so it's important that they really get all the information from each unit before we move on. And that work can be resubmitted for partial points back. That's to encourage students to want to fix those and gain the understanding. I would also note that this is an honors level class, and it is, again, one of our Project Lead the Way classes. It is available for college credit through the Project Lead the Way network. And the final grade for the class and the college credit grade is based upon the Project Lead the Way final exam. This is the national exam that is designed and given by Project Lead the Way. And those of you who have students who have taken some of these classes before may be familiar with the exam. And we tend to have a pretty high success rate. And, again, this class as well follows that trend. So that's really all from me for digital electronics. If you have questions, please feel free to email me or have your student contact me through Classroom. And I hope we have a great year. Thanks. Bye-bye.